Hello friends, welcome to Coding Garden with CJ. Welcome to Code Katas number 7. Well, we're gonna break things down, one step at a time. We're gonna solve these katas, you and I. We're gonna break things down, one step at a time. We're gonna solve these katas, you and I. Code Wars, Code Katas, Code Wars, Code Katas, Code Wars, Code Katas, yeah. Welcome to the show. Rohit, welcome to the stream. James, welcome to the stream. Tuning guitar. I actually was tuning my guitar. Awesome. Welcome to Code Katas. So if you're not familiar with the show, you can check out github.com/codinggarden/code-katas, and you can see all of the previous katas that I've solved. And for tonight, you can see the links of all the ones that I plan to solve tonight. So let's get into it. Go ahead and open all these up and talk about them before we start. This first one is a 7Q. It's called Isograms. We'll then do another 7Q called Categorize New Number. We'll then do a 6Q, which is multiples of 3 or 5. It's kind of got like a fizz buzz ring to it. I don't know. There's also a 6Q, which is convert string to camelCase. Then a 5Q, where my anagram's at. Another 5Q, RGB to hex conversion. And lastly, Priori Incantatem, which was suggested by James, who's in the chat. This one is actually pretty difficult. We're saving that one for last. We'll start with the easier ones and then get gradually more difficult. So let's get started. We're going to start with isograms. An isogram is a word that has no repeating letters, consecutive or non-consecutive. Implement a function that determines whether a string that contains only letters is an isogram. Assume the empty string is an isogram. Ignore letter case. Okay, let's copy our example cases and give this a try. Cool. I think the way that we can determine this is count up the counts of all the letters in the string, and if at any time one of those counts goes above 1, then it's not an isogram, right? Because an isogram, let's make sure we have this right, has no repeating letters, consecutive or non-consecutive. So basically the same letter cannot occur twice. So we've solved a similar problem before on the stream, but essentially we need to count all the letters in the string. So let's do this. First thing is we are going to need a place to store the counts. So we're going to have somewhere where we can keep track of the count of each letter. We are then going to iterate over the string, and we will see if we have seen this letter before. If not, then we'll add it to the counts with the count of 1. And else, if we have seen it, then not an isogram. We could immediately stop what we're doing and say, hey, that's not an isogram. Kaizen, welcome to the stream. Hello. Check my phone real quick. Cool. All right, let's do this. So for a place to store the counts, we're going to use an object. So let's say counts is an object. And then we need to iterate over the string. So we'll just have a for loop. Let I equal 0, while I is less than string.length. I++. And I guess we also forgot, if we get done with this for loop and have figured out that all the letters do not occur more than once, then it is an isogram. So, gotta remember to do that. See if we've seen this letter before. So let's create a variable. Let's call it letter. We'll set that equal to the string at index I, and see if we have seen it before. So we'll say if counts at letter. So we're just going to use bracket notation to see if this letter is inside of the object. And let's do this. If not there, it means we have not seen it. So we'll say counts at letter equals 1. And if we have seen it before, then we instantly know that it's not an isogram. So we can just return false. And that will immediately exit the for loop, immediately exit the function, and return false. And otherwise, we will return true, because we made it through the whole for loop, and we didn't see a letter more than once. All right, let's give it a try. Sample tests. Oh no. Okay, we forgot to account for something. So the tests are failing right now. It says same characters may not be the same case. Expected false, but got true. So one thing we need to do is when we grab the letter, we need to convert it to either lowercase or uppercase, so that if we come across the same letter that is either uppercase or lowercase, then we know that we've seen it before. So when we grab the letter out of the array, let's just do .to lowercase. And we'll see what happens. Oh no. Sample tests. Passing. All right, we'll try a little bit more. Attempt. Awesome. So it's a pretty basic solution, but let's try to do it with some higher order functions. So I'm going to bring this down locally. Let's create a new file, isogram.js. And basically, here's the thing. We could use a reduce here, right? Because we're ultimately turning this thing into an object. However, a reduce will always iterate to the end of whatever you're iterating over. And what we're doing right now is we're breaking out the moment that we find that something is in there twice. So we don't want to use a reduce. I think we can use another higher order function called any. I think it's any. I always confuse it. Any, or maybe it's sum. I think it's called sum. Yes, sum. The sum method tests whether at least one element in the array passes the test implemented by the function. So basically, for every letter in the array, we can do this test, and if any of them return true, then we return false, because that means we found the letter more than once. All right, let's try it. Okay, so instead of doing this for loop, we do need to iterate over it. Sum is on the array prototype, so we can turn it into an array and then use it. And then I'll show, I will show after this how you do it without turning it into an array first. So we want to return string.split on the empty string. So that will turn that string into an array, so we can use the sum method. And this takes in a function that's going to give us the letter. Oop, got some extra parentheses. Or do I? Okay. And basically, we want to do this inside of here. But we want to return true if it has seen it before, and we'll return false if it hasn't seen it before. So right now, this will return true if one thing is repeated more than once, and we want the whole thing to ultimately return false if it's repeated more than once. So we're just going to negate this entire sum. So let's try it out. We'll try it on Code Wars. Oop, oop. There you go. Sample tests. We forgot to do the two lowercase thing. So we'll do that right here. We'll say letter equals letter dot to lowercase. Right about there. Sample tests. It's passing. Cool. So I do want to show, instead of splitting this, we can use the sum function on the array prototype and call it with our string. So let's try that. So we will say, instead of just calling dot split and sum, we'll say array.prototype.sum.call. So we're going to invoke the function with the string as the this of the sum function. And the function that will pass it will run across that string. Let's take a quick stretch. I'm drinking two things tonight. I've got my yerba mate and my water. Okay, this should work in exactly the same way, but we don't have to turn it into an array first, which is what we were doing here. We're just using the built-in prototype method to call that on our string. Let's see if this works. It works. Final attempt. Well, I think one more. Submit final. It's working. Awesome, it worked. Cool. Let's see how other people did it. So this first one actually just used a regular expression. This is checking for any character and one occurrence of it across the whole string. Very interesting. This one is using a nested loop. So basically, we loop across the string, and then we loop again to compare it with every other letter. And if at any point they're equal, we know that it occurred twice. This is actually not as performant, though, because it's a nested loop. So it has a higher complexity, whereas this is a single iteration of the string, and then it breaks out the moment we know that it's not an isogram. Oh, very, very interesting solution. Okay, so they're using set, which is a new thing in, well, I say new, but it was introduced in ES 2015. But basically, a set is a data structure that only allows things to appear once in them. So what they do is they pass in the string to the set, and basically if there were any duplicate characters, those would get removed, and then they compare the size of the set to the original length. So if there were no duplicate characters, the size and the length would be exactly the same, but if there were duplicate characters, the size wouldn't be the same. That's an interesting solution. Another regular expression. This is a nested loop in disguise. So this is still n squared, but you'll notice the use of index of, and this has to search the whole string. So essentially we're iterating over the string and then searching the whole string at the same time. So it is a nested loop. Okay. Let's move on to the next one. Categorize new number. The Western Suburbs Croquet Club has two categories of membership, senior and open. They would like your help with an application form that will tell prospective members which category they will be placed. To be a senior, a member must be at least 55 years old and have a handicap greater than 7. In this croquet club, handicaps range from a -2 to a +26. The better the player, the lower the handicap. Okay, lower numbers are better. Input will consist of a list of lists. We're going to get an array of arrays with 2 items each. Each list contains information for a single potential member. Information consists of an integer for the person's age, so this is their age, and then their handicap. Okay, so our output will consist of the string values open or senior, stating whether the respective member is to be placed in the senior or open category. Okay, so we know they're a senior if their age is 55 or older. And we know if they're in open, if their handicap is, where does it say it? Handicaps range from -2 to 26. The better the player, the lower the handicap. Input will consist of, okay, output will consist of a list of string. Oh, I guess, oh, I see. If they're not in the senior category, then they're in the open category. But do we have to take the handicap into account? I don't know. Let's take a look at the sample input, and let's also look at the example output. And we'll take note that senior is greater than or equal to 55. So we know that. Okay, so this person was put in open. They are younger than 55. This person was put in open, senior, open, open, senior. I think all we have to take into account is the age. If the age is greater than or equal to 55, they're senior, otherwise they're open. Maybe the test will reveal some other thing about it. Let's try it out. So first thing, we will need an array to store the categories, which is going to be our ultimately the result that we return. And then we need to iterate over the data. Whoa, sorry about that. And then we'll check if the current item index 0 is greater than or equal to 55. If so, we will push senior into categories. Else push open into the categories. And then lastly, we will return the categories. Okay, we'll solve this initially with a for loop, and then we'll try to use a higher order method. So first thing, an array to store the categories. We'll just say categories. I think that's what they are. Categories. And I'm going to bring this down locally just so I can scroll around a little bit more. New file, categorize, new member.js. Okay. Okay, so now we need to iterate over the data. And actually, that should be indented like that. So we have a for loop. And we'll just call this I. We're going over data.length. And let's call this member. And that will be data at I. Now, we know, whoa, excuse me. We know that member is actually going to be an array itself because this is an array of arrays. So member is an array of length 2. So we could create another variable called age that is member at 0 because this will be the age of each element. And then we'll say if age is greater than or equal to 55, categories dot push senior, else categories dot push open, and then we'll return the categories at the end. Okay, let's give it a try. Sample tests. Okay. I think here's the thing. Oh, 55 or younger is open. So I made the mistake here. So notice how it says expected output is open, 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 open. Instead, I got open senior, senior open. I categorized. Oh wait. Okay. I think here's, so for one, 55 is not a senior. It's above 55. And then the other thing, which I can't exactly read here, is, or I didn't see it in the description, is if their handicap is low, then they're actually in the open. Input will consist of a list of lists containing 2 items each. Each list contains information for a single potential member. Information contains an integer of the person's age and an integer for their handicap. Does it say, how do we determine if... Okay, for one, I don't know anything about croquet, so maybe I'm missing something there. How do I know if a score is something that would make them in open. Yeah, and so Kaizen in the chat is saying, don't the handicaps matter? They do, but I don't know how to check that. So for one, we'll fix this real quick because age needs to be greater than 55. If we look at their example output, I see. So if the handicap is within this range, then they are in the open. Okay. -2 to 26, because this person is 91, but their handicap is a -2, so they're actually in the open. So I think we need to account for that range there. So if age is greater than 55, and we'll also store the handicap, and that's going to be member at 1. If the age is greater than 55 and handicap is greater than 26, 27, because 26 should be allowed in, then they're in senior. Otherwise, they're in the open. Let's try it. Okay, now, I don't know what I'm doing. Okay, so expected open, senior, open, open. Instead got, oh, well, if age is greater than 55 and handicap is greater than 27. Yeah, so handicap is 7+. Where did you see that? Oh! A senior member must be at least 55 and have a handicap greater than 7. I see. I missed the directions. Cool. So if age is greater than 55 and handicap is greater than 7, well, I guess we would say less than 7 because lower is better, then they're a senior. Like this person has a handicap greater than 7 because it's negative. Okay. I think we're on the right track now. Read the instructions. Always read the instructions. Sample tests. Now everything is broken. If age is greater than 55 and handicap greater, okay. Maybe they did mean greater than or equal to 7. Because I read that as lower handicaps are better. Wait. Or higher handicaps better? We're going to go with this. Sample tests. Okay, so right now, everything's good except for this one case. So instead of open, this person, the second person, should have been considered a senior. So it is greater than or equal to 55. Yes. Because in this case, the second one is open, but their score is not better than. Okay, I think we got it. That really took some, for me at least, like really analyzing the instruction. Oh, really analyzing the instructions. Okay, decent, and seems to work. Should be greater than 7 expected. Does that mean we don't need greater than or equal to? Okay, cool. That's great. We figured out the logic. Now let's do this with some higher order functions. So one thing we can do is use a map, right? Because we're taking this array of data and turning it into a new array of data with different values. So a map is going to allow us to either return senior or open, so we end up with a new array. So let's do that. Okay, so ultimately we want to return data.map, and we're going to get access to the member. And we have all of these things. And now instead of pushing senior, we will return senior. And instead of pushing open, we will return open. Cool. This should work, but we can also use destructuring. So notice how we're grabbing the two variables here from the array. Array destructuring works like this. We can say the first value in the array is age, and the second one is handicap. I see Kaizen in the chat says he played golf, so that's where he's coming from. I have never played golf more than just going to a driving range, so I don't know much about the domain. Okay, but this will actually work in the same way. But basically, destructuring can take the parameters of a function and break them up. So you can do it with objects, but you can also do array destructuring. So this should do what we want. There we go. Attempt. All right. Very good. Is there anything else we can do here to clean this up? We could turn it into a one-liner. Why not? That's not cleaning it up. That's just having fun. Okay, so if age is greater than or equal to 55, so we're going to turn this into a one-line fat arrow. So if that, then senior, otherwise open, and that's it. Cool, it works. I'll submit this one. Attempt. Submit final. Guess I should be using my soundboard. Yeah, that thing. Cool, it worked. Awesome. This person did a very similar solution. They did wrap this in parentheses. I don't think you need to do that with the ternary, because essentially anything before the question mark will be interpreted as a conditional, like something that resolved to either true or false. Cool. This person just did a map with a nice readable, more readable function than something that's just inline. This person got even trickier. And this was our, oh, they did a for each instead of a map. Cool. All right, moving right along. This next one, multiples of 3 or 5. This is a 6Q. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Finish the solution so that it returns the sum of all multiples of 3 or 5 below the number passed in. If the number is a multiple of both 3 and 5, only count it once. Okay, cool. Let's copy this description, all of it, and give it a try. Actually, I will bring this down locally. Multiples of 3 and 5. Oh, I didn't name it .js. .js, cool. Awesome. Okay. We get, so if we list all of the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum is 23, so that's what we return. So basically, we need to count down from the number, check each number to see if it's divisible by 3 or 5, and then add them all up. Finish the solution so that it returns the sum of all the multiples of 3 or 5 below the number passed in. If the number is multiple of both 3 and 5, only count it once. I see what that's saying there. So if you come across 15, it's divisible by 3 and 5. So it is, wait. Yeah, it is divisible by 3 or 5. So you don't want to count it twice because it's divisible by both. You only want to count it once. I see. Okay, so we will need to iterate down from the number -1. I think we don't include the number itself. Yeah, we don't include the number itself. And we will need a place to store the sum. And we'll say if the number is divisible by 5, then add it to sum. Else, if the number is divisible by 3, add it to the sum. I think that should do it. And mainly, as long as we're using this if-else, we're not counting the number twice. Hello all, welcome to the stream. And yeah, Kaizen is saying it's almost like FizzBuzz. It definitely is. If you haven't seen or heard of the FizzBuzz thing, it's a pretty common interview question where you have to, if a number is divisible by 3, you say fizz. If it's divisible by 5, you say buzz. If it's divisible by both, you do FizzBuzz. And if it's divisible by neither, you just log nothing. But okay, so we need the sum. We'll start that off at 0. Then we need to iterate down from the number -1. So we'll have a for loop that goes from the number -1 while I is greater than 0, I plus. Then we will do these things. Whoa. Amal says, plot twist, use reduce. Absolutely. One thing I like to do on the stream, though, is I'll solve it without, well, just using like basic for loops first, and then we'll solve it again using like a higher order method or something like that. Okay. If the number is divisible by 5, add it to the sum. And using reduce, so it'll be a little bit tricky because we don't want to include the number itself. And actually, we don't have an array to reduce over, so we'd have to create an array, but I'm going to do that. We'll do that after this. Okay. If the number is divisible by 5, so if number mod 5 is equal to 0, then add it to the sum. So sum plus equals the number. Else, if the number mod 3 is equal to 0, then we will add it to the sum. So sum plus equals number. And then that's it, I think. And then we'll return the sum. Let's see what this does for us. Sample tests. That's taken a while. There's only one test in here, isn't it? Execution timed out? What? I have a single iteration. Oh, oh, I++. Of course it timed out. That is an infinite loop. There we go. Expected 23 got 90. Okay, I'm doing something very wrong here. Let's do this locally. We'll just do the 10 and expect it to be 23. Oh, I'm adding the number. I want to add I, and I want to check for I. I'm being sloppy tonight. I will say I just woke up from a nap right before the stream, but Sorry. Here we go. Okay, let's double check our solution. So I is equal to number minus 1. We're decrementing I, so we're going down while it's greater than 0. If that given number is divisible by 5, increment sum. If that given number is divisible by 3, increment sum. Okay, I think this will do it. Simple test. There we go. All right, let's clean this up and potentially use a reduce as well. So one thing is, we should be able to just check 5 or 3. We don't really need the else if. So that should work in the same way. And let's just log this. So if we log solution with 10, we should see 23 also. Cool, so that still works. And let's try to use a reduce. So the thing about a reduce is we need an array. So let's create one. I'll do this as another solution. And we can do that with just by saying new array and give it the length, number minus 1. The thing about this, though, is if you reduce an array that was created this way, it actually doesn't have any values in it. So we actually need to fill it. So we're just going to fill it with zeros and then reduce that. So that's going to give us something we don't care about, and then I, the index of that. And we want to return this whole thing. And yes, we are starting at number minus 1. And really, we just need to do this check right here. And we need the accumulator. So we have accumulator, the current element, which is just going to be a bunch of zeros, and then the index itself. And we're going to start the accumulator at 0. And in this case, we'll return sum plus I. Otherwise, we're just going to return the existing sum. All right, let's give it a try. That didn't work. Let's log what array we're getting from here. Should be the index, right? The reducing value, the current element, and then the index in the array. Array from, and you can actually pass it. Interesting. I'll give that a try. And then, yeah, let's log the fake array. What's happening here? One, 2, 3, 4, 5, 6, 7, 8, 9. We do have 9 numbers. We are returning the current sum plus I, otherwise we're returning the sum. Let's actually log I if it's divisible by that number. Zero. That should be okay. 3, 5, 6. We're not getting 9 though. Why aren't we getting 9? 0, 1, 2. Oh, because the index. We got to do index plus 1. Okay, let's do this. We'll say num equals I plus 1. And then we'll check for the num itself. There we go. Give that a try. There we go. Sweet. Reduce takes an accumulator and the current val. That's what we have there. So I am going to try what Amal is suggesting here. So array.from. And I will look it up to see that syntax. So you're passing in, oh, interesting, because array.from takes an array-like object and a function to apply to each thing inside of it, and you're giving it an object that just has a length property. So array.from is assuming that this thing has that many things inside of it. That's pretty cool. Let's use that. And we don't need to create this fake array anymore. So instead, we can say array dot from. The first parameter is going to be the length. And that's going to be, well, we want it to be number minus 1. I guess technically, if we did it as number, then the indices, I wouldn't have to add 1 to the indice. Let's take a quick stretch. Because if we started, if we gave it length of number, then the last indice will actually be 1 less than the number itself. So that actually could work. So if I do number and then just use I, now let's comment this out for a second. So now we're just creating an array with that number and checking I. That works. Very cool. So we'll do the same thing with this array.from. And we are giving it a function where we don't care about the first thing. I guess that's a pretty common pattern in your functions. Like if you don't care about that thing, call it dash. And I, and we just want to return I. So this should give us, an array with just the indices inside of it. We don't need to fill it anymore, and then we can reduce it. Oh, I am still doing number minus 1. Cool. Oh, I see, and I see now that we're using array.from. Before I was filling it with zeros, so I had to use the index, but now we're grabbing the number itself, so we can just use that. Thanks for the tip, Amal. So we can just call this I, or num, but that should still work. Sweet. I like that. We could turn this, let's turn this into a one-liner just because. It's going to be ugly, but we'll say this. Zoom way out. Okay. Get rid of that. If that is the case, then we want sum plus I. Otherwise, we want sum. That. And we can get rid of all of that. And we'll start it off at 0. Cool. Let's try this one out. It works. All right, I'm going to submit this one. And thanks for the array.from tip. I think though, like technically array.from, and I guess fill does too, but array.from has to iterate over the array. So instead of using a reduce, we could have like an external variable and like do the logic inside of this function. Let's just do that real quick. Because technically this is 2 iterations. We have to iterate to create that array and then iterate to do the reduce. So here's what we'll do. We'll create our sum outside of it. And then we'll do this inside of our function here. And then we will return sum. Cool. It's not as functional because we do have like external variables, but this should still do the same thing because this function is going to run for every element up to I. Cool. I like this one. I'm going to submit this one. This is actually a pretty neat trick rather than having to, because a lot of times when you do need a for loop and you don't have an array, you could use something like this because this basically is going to execute this function up to the number that you give it. So that's pretty cool. Attempt. All right, drum roll for the final submission. More drum roll. Code Wars is being slow. I was trying some katas last night and it was being very slow. Oh, it won. Yay! Cool. Let's see how some other people did it. Yeah, just your basic run-of-the-mill for loop, incrementing sum. Cool. This person found an actual formula to do this. So there are various variables involved in 3, in 5, and in 15. You plug those into this formula, and that will give you the sum of all the multiples of any number lower than that. That's pretty cool. Basic for loop. Some arithmetic sequence. Yeah, so this is that same formula with just like different variable names. Very cool. Yep. And let's just look up array.from while we're at it. Array.from creates a new shallow copied array instance from an array-like or iterable object. And the thing that we gave it was an object with a length property. So according to this is array-like because it has a length. I'm also saying find that person now and ask them to explain the code. Like, I think honestly, like you could probably find this formula on on Wikipedia. But I mean, if you wanted to explain it, you might need some sort of like mathematical proof. Let's just try to look it up because that's pretty interesting. Sum of multiples below number. Number theory. Quora. I mean, there's a lot of places with like a similar problem with what we just solved. Ah, okay, so it's not specific to this, but we're basically saying that the sum of all natural numbers up to n is this formula, okay? And then given that formula, we know that all numbers that are multiples of 3 give us this formula, 3 times all natural numbers up to the number divided by 3. Interesting. Don't feel like going any deeper into that, but array.from is really cool. I'm probably going to use that a lot more often. So like you can pass in an actual array, but the cool thing about it is you give it a function that will be called on every element that you pass into array.from. Cool. All right, on to the next one. Should be pretty easy. I say that and it never is. Complete the method or function so that it converts dash or underscore delimited words into camelCasing. The first word within the output should be capitalized only if the original word was capitalized. Okay. Actually, I will bring this one down. We want camelCase.js. Yeah, Kaizen in the chat is saying, hate those ugly one-liners and nonsensical variable names in Code Wars. For whatever reason, those seem to be the ones that are, like, in the, I guess I don't have it open anymore, but in the results that you see afterwards, apparently those are the most commonly submitted solutions. Like people that have similar looking code, it'll show that there. But yeah, for whatever reason, people like to use short variable names, one-liners. I don't know. It's fun for problems like this, but if you're in a real code base with a real team, it's not a good idea because it takes more effort to understand what your code is doing. Yeah, it's not the best. Cool. Let's try this out. And Amal is saying it should work for a generator as well. You're talking about the previous problem? I guess I'm curious how that would work. Would the function... Oh. I think I see what you mean. So you have a generator that starts at like number -1, and then each time you call it, it returns that number -1. That would be an interesting way to solve that previous one. Okay. So we are given a string. It's either separated by dashes or underscores. So we need to, I'll say like split the string by a dash or underscore. And then, and really, this is probably one we'll use a reduce for. We can do it without a reduce first and then convert it. Iterate over the split string. We're going to need a place to store the camelCase string. Okay. And append the current word capitalized to the camelCase string. And don't forget to, I guess, skip capitalizing the first word. So we'll have to check like if it's the first word or not. And then we can return the camelCase string. I think that should do it. Okay, let's try to do this with like a few variables, and then we'll like try to start to compact the solution. So first, split the string by dash or underscore. Does split accept a regular expression? Actually, I want to see what are some of the other things that they pass into it. Yeah, so either dashes or underscores. Let's check out string split on MDN. Separator. Okay, we might have to first try to split it on dashes. The separator is treated as a string or as a regular expression. Okay, so we can do a regular expression. So we'll say this. We'll say words will be string dot split, a regular expression that matches either dash or underscore. Global. Do I need to escape dash or underscore? I don't think so. Do I? No, I don't. Okay, so split it on either dash or underscore. Then we should get the words. Now we need a place to store camelCase. So we'll say let camelCase be an empty string. We'll then iterate over the words. So we need a for loop. Whoa. We're going to go to words.length. And we'll say if I is equal to, actually, let's do this. So I was going to check to see if we're on the first word, but one thing we can do is before we go into the for loop, we'll just append the first word to the camelCase string because, whoa, sorry. Because then we can iterate from 1 up to the length. So we'll actually set camelCase equal to words at 0. So we're off to a good start. camelCase has the first word in there. And then we'll append each one. So we'll say words plus equal, camelCase plus equal words at index I at index 0. So we want the first character to uppercase. And then we'll also add the rest of the word without the first word. So we should be able to do, maybe do slice at 1. And then we'll return camelCase. So split it. We should then get an array with several words inside of it. Take the first word and put it on camelCase. Then iterate for every other word after that in the words array. We're going to append the first letter of the current word capitalized, and then the rest of the word. So slice should give us the rest of the word. We could also use substring or subter there. And let's just create a variable. We'll say word is words at I, and we'll use word here. Okay. Let's see what happens. Sample tests. Oh no! What did I do wrong? Hey Ron, welcome to the stream. James is saying the first character should be lowercase. The instruction said that the first word should be capitalized only if the original word was capitalized. Now, what the heck happened here? So, oh, you know what? My split function might not be working. Let's test this out. Okay, yeah, let's run this locally, and, oh, that's why. Maybe my split function is working. We will test this locally. I accidentally said words.slice instead of word.slice because I had created this variable here. That was probably the issue. Okay, yeah, let's run this locally and see what happens. So, the stealth warrior. I think it's working. Yeah, I copied the test cases, so it's logging that extra thing. But yeah, I think this is the one. Yeah, I'm all saw my error. Here we go. Sample tests. There we go. All right, let's do this with a reduce. Okay, so we definitely want to split the words. That's great, but we'll return this whole thing, and we're going to be reducing it. We're going to get camelCase, and we're going to get the current word. And we want our reducer, or our accumulator, to start off as an empty string. Actually, yeah, so this is going to make it a little bit trickier because we don't want to capitalize the very first thing in there. So we want to do this. We want to say return camelCase plus word at 0 and then word.slice. However, if the index is equal to 1, we want to leave it the way it is. So return camelCase plus, well, actually, oh, okay, easy enough. If index is equal to 1, just return the word, right? So if index is equal to 1, then just return the very first word. Otherwise, we'll do this, because then on the next iteration, because we returned word on the, index equals 0, sorry. Because we returned word on the first iteration, when it comes back around, our accumulator will be the first word. So I think that will do it. Let's try it out. Yeah, cool. Let's try it on Code Wars. Sample tests. All right. Can anyone think of other ways to do this? Yes, we did need the index, and this was the main reason. Here, I'll write this without the ternary just so it's a little more verbose. But basically, if index is equal to 0, then return the word. Else, well, we don't really need an else. We can just say return this thing. That's basically what this ternary is doing. Yeah, I mean, we could probably do this in a single iteration, like one single for loop where we're looking at every letter at a time. I have a few more katas to do tonight, so I don't think I want to write it that way, but this is good. Let's convert this to a one-liner and then submit it. So really, because we have just a single return statement, we should be able to do that. Cool. Great, right? No, it's not great. We could use like one letter functions. James is saying this would be easier in Ruby because they have a capitalized function. Definitely. Actually, let's do that. Let's make a capitalize function that we just call right here. So we'll say capitalize. Actually, we can define it outside of there so we can do it multiple times. Capitalize the word, and we want to return this, and then we'll say capitalize word, and then we'll do the same thing here. Still works. Map for each. Yeah, definitely. Yeah, so for a for each, it'd be very similar to our for loop solution, but instead of doing a for loop, we could do a, basically this code would be inside of your for each. The issue there is you would want to check for the index because for each is always going to iterate from the beginning. So you would need to, you could either slice the array so you're not looking at the first value, or have this logic like we do inside of the reduce where we're not looking at the, or if it's the first index, we just return the word itself. Cool. Let's do this one, or submit this one. There we go. Attempt. Drum roll, please. Oh wait, and for the final solution, I will drum roll. Drum roll. Drum roll. Oh no. Crap. We did it. Let's see. Ooh, this person used a regular expression. Okay. I see. Any word, so any, I really like, okay, so any dash or underscore followed by a word. So this will skip the first thing because that's there. And then anytime we find this, so any dash or underscore followed by a word, we just make the match in uppercase because that will match that specific word. That's really cool. I like that. Same thing. Oh, and this is matching, wow. Okay, so this is matching the first character after a dash or an underscore and just uppercasing that specific character. Very cool. Everybody used a regular expression. Oh, okay, so split, map. They're using a map and then a join. This is definitely a better case for a reduce, though, because a map and a join is going to be multiple iterations, whereas your reduce, instead of like creating an array and then putting it back together, you're just creating the string all in one go. Camelize. This person put a function on the prototype, the string prototype. Cool. Very interesting. All right, moving right along. Where are my anagrams at? Okay, so what is an anagram? Well, two words are anagrams if each other if they both contain the same letters. For example, ABBA and BAAB are true. ABBA and BBAA are true. ABBA and ABBA are false. So basically two words that have the same number of characters of each character type inside of that word. So write a function that will find all anagrams of a word from a list. You will be given two inputs, a word and an array with words. Oh, I forgot. So the one issue with this one is they don't have any sample tests for us. We always have to attempt our solution, which is pretty lame, but let's give it a try. Anagrams. Okay. So the way I'm thinking about this is first we count up the number of occurrences of each letter in this word. Then we count up the number of occurrences of this word and make sure that all of the counts are the same, and do the same thing with every word inside of it. That should be good. And ultimately, that will just be several iterations of each string, but there's not going to be any nested iteration. One way someone might go about this is if they basically, every single word in here, they compare it with the input word, and that's going to be some nested loops multiple times, so it could get pretty complex. Kaizen says, thanks for the morning dose of logic. Head out. Good luck with the rest. Au revoir, mon ami. Cheers. See you later, man. Have a good day. Ran, oh, that's a good suggestion. So Ran is saying sort it and then compare, because if it's sorted, then it would be exactly the same string. I think the issue with that is sorting potentially is going to be have higher complexity than just doing a single iteration. But let's do that first, and then we'll do the solution that I was talking about, which is count all the letters up. So let's say sort characters in Word. Then we'll iterate over words, and we need a place to store the anagrams. And then if the current word, then we will sort the characters in the current word. If the current word sorted is equal to the sorted word, push into anagram. All right, that should do it. And then we will ultimately return the anagrams. Anagrams, cool. I'm curious if sort will just work by default, or will we need it to give it a comparison function. So if we say A, B, B, A, split it. So this is actually going to be a lot of iterations. So we have to turn it into an array, sort it, and then turn it back into a string. So split it, and then sort it. Does that work? Yeah, that works. Okay, so we can do a sort without any comparison function of our own, and then we want to join it back together on the empty string. Yeah. So let's write a little function that will do this. So this takes in the word and then returns that of the word. This could be a case where we use the array prototype sort. Maybe not, though, because it's like pushing into an array. Okay, cool. Amal has a suggestion to spread the word into an array and then sort it. So yeah, so instead of splitting it on the empty string, we can spread it, which will create an array with all the characters inside of it, sort it, and then join it back together to an empty string. Cool. So we have our little function. We'll say sorted word equals sort word with word. I want to name it something else so I don't confuse myself. It should be fine. It should be fine. Okay, so now we have our sorted word. Then we need a place to store the anagrams. It'll be an empty array. And then we will iterate over the words. So let I equal 0, while I is less than words.length. We could definitely use a higher order function for this. We'll probably use filter. We'll filter out the words that are anagrams and return that. But we'll do it with a for loop first. So sort the characters in the current word. So current word sorted will be sort word with word, and we'll create word inside of here. So word will be words at I. And then if the current sorted word is equal to the sorted word, so if word is equal to, if the sorted word is equal to the current sorted word, then we will push into the anagrams array. Current word sorted. Let's take a quick break. Hey, Emmy, welcome to the stream. Hello. I hope I'm not mixing up my variable names. So we have a function called sort word. Sorted word is the word passed in that is sorted. Array of anagrams. Word inside of the for loop is the current word in the words array. I want to rename this. Let's call this current word. And then the current word sorted is the current word passed into the sort word function. If the sorted word is equal to the current sorted word, push it into anagrams, and then return the anagrams. Okay. Let's see if I can pull down some sample. Oh, actually no, this one didn't have sample tests, so we do have to. We could test it ourselves. I'm just gonna put it on Code Wars, see what they have to say about it. Yeah, because there are no sample tests, so we'll do an attempt. Value is not what was expected. Case sensitivity, good call. So Amal is saying we need to account for the case. And we kind of need to do that here. Actually, I guess we can call 2 lowercase on the entire word, right? That should work. Yeah, of course, of course. Yeah. So after let's actually just do it up here in our sort word function, 2 lowercase. Here we go. Attempt. Value was not what was expected. Let's try it out locally. So let's say we're going to log. Did they give us example input? They did. Let's do this. Oh, we don't want to push the sorted word. We want to push the word itself. So we were pushing in the sorted word, so we weren't getting back the actual input word. That makes sense. There we go. Okay, cool. But I'll tell you what, so this is a solution to it, but I'll tell you why I don't like it. So for one, to turn this word into an array, that is 1 iteration. So let's count the number of iterations. Array, 1 iteration. To then sort it is potentially n times n. There's probably an optimized solution so that, like, if you look into the complexity of sorting methods, this is probably like n log n. So this, to turn it into an array is n. To sort it is n log n. To join it is then another iteration. So that's n. And then 2 lowercase is another iteration. So this one function, ultimately, it's 3n plus n log n. So this function has a complexity of n log n. And then this has a complexity of n. So like this one for loop has a complexity of the length of the array. Well, I guess length of the array would be a different variable. So this has a complexity of, we'll call this n log n. This has a complexity of m because it's a different length. And I guess each word is a different length, so maybe that should be m2. Yeah, let's call this m. So this is going to be m log m. This is going to be n. And because we're doing this sort word inside of the for loop, the whole complexity of our algorithm is n times m log m. And I think we can do better than that. Cool, let's do better than that. And the way we do better than that is just a single iteration. We're not going to do any sorting or anything like that. A single iteration of every word, and then iterations of the counts that we come up with, and ultimately it'll just be n. So no more than one iteration. So here's what we'll do. We will count the occurrences of each letter in the input word. James is saying this is hurting my brain. Apologies. It'll be over soon. Actually, now that I think about it, though, we are gonna have to do some counting inside of the array, the for loop iteration itself. But it's only going to, we're going to do it. We're going to do it anyways. Okay, count the occurrences of each letter in the input word. We then need a place to store the anagrams. Then we'll iterate over words. And we'll count the occurrences of each letter in the current word. And then we'll compare the counts with the input word. If not the same, we'll say if the same, push into anagrams array. Rand said, I need to learn more about determining complexity. There are a ton of really good YouTube videos on it. This is a quick aside. I think a while back on my morning tea stream, I came across an article that talked about that data. This one, algorithms and data structure in JavaScript. And this person made a GitHub repo with all kinds of computer science resources for JavaScript. Where is it? Here it is. And inside of there, they do talk about complexity and how to calculate it. So you have your data structures, algorithms, and is there big O? Yeah, and then big O notation. There's also a whole YouTube thing on data structures and algorithms. And I believe in here, they talk about big O notation. Yeah, so there's a HackerRank video on talking about big O notation. And I believe HackerRank has a place where you can practice doing big O notation for developers, solve challenges now. Cool. We can do algorithms, I think. May not be in there. Yeah, and James is mentioning the Big O cheat sheet. So they did link to that here. And this comes from the Big O cheat sheet, which is common algorithms and common data structures, and then the associated complexity with given methods on a given data structure. So what I was talking about a second ago with in log in, that's like best case for sorting algorithms. Cannot do any better than in log in, pretty much any sorting algorithm. And I'm hoping that the JavaScript engine that we're using is using like a highly optimized sorting algorithm. Some of the worst ones are like bubble sort, because that's like n squared complexity. Cool. So check that out. Lots of good resources there. Lots of cool YouTube videos. Let's do this. Okay. a place to store the anagrams, iterate over the words, count the occurrences. If it's the same, push into the anagrams array, and then lastly, we will return the anagrams array. Okay, so I'm going to write a little function that creates the counts, count letters. This will take in a word, and we're going to reduce it. So we'll do array.prototype.reduce.call. We're going to call it on the word. We're going to give it a function where we get back the counts, and we're looking at each individual letter, and we're reducing to an object. And we'll ultimately want to return the counts, but we want to say counts at the given letter is equal to, is equal to itself or 0, then we'll increment at that location and return the counts. So this should give us an object that counts all of the letters. I've probably done this like 5 different times on code katas because a lot of different problems that we're solving have us do this. So check out one of those videos for a more slower explanation of what's happening there. But we can now count the words. So we'll say word count, or let's call this letter count, is going to be count letters with the word. And right now, let's just log that out so you can see what's actually happening. So basically, our input string, we're creating an object where it has the properties of each unique letter and their counts. And we do have to remember to do 2 lowercase, because we want to account for case. Cool. So now that we have the counts, we need a place to store the anagrams. And now we're going to iterate over the words. So something like this, but with something very different inside. Count the occurrences of each letter in the current word. Whoa. So we're going to say current word letter count is equal to count letters with the current word. And the current word is words at I. Compare the counts, and if they're the same, push into the anagrams array. So we'll write a function to do that for us. So we'll say if honestly though, we could do a loose equal, because we could compare the 2 objects to make sure that all their properties are the same, and if that's true, then it is an anagram. So we'll say loose equal with the current word letter count and the letter count. And if those are loose equal, then we're going to push the current word into the anagrams array. So we'll say anagrams.push current word. And then we'll return the anagrams array. Anagrams. Cool. Amal is mentioning case sensitivity. I believe I'm accounting for that here whenever we do the count of the letters. So for instance, if we put a capital B there, oh, loose equal doesn't exist yet. Let's get rid of that. If we put a capital B, oh, we're not logging the, dang it. Log the letter count, please. If we put a capital B, we're still accounting for it because we lowercase it before we put it into the object. So should be good. Yeah, now we need this loose equals thing. So loose equal will take in some 2 objects. So object 1 and object 2. And we want to return if both of those things are equal. So basically, we need to look at the properties of every single one of both objects and make sure that their values are exactly the same. And if they all are, then they are loose equal. I think we can use a higher order method for this. is every a thing? Yes, it is. So every method tests whether all elements in the array pass the test implemented by the provided function. So we're going to use every on the keys of the first object to make sure that its values are equal to the values of that given key in the second object. So we're going to say object.keys of object1 every. This is going to give us the letter. Let's take a quick stretch. My back is tight today. Okay, so if every letter, and we'll say object1 at that letter is equal to object2 at that letter, then we know that they're loose equal. So basically this says does, and really, like, if we want this to be like generic, we can call this like key, but really what they are the letters inside of our count object. And so if object1 at that key is equal to object2 at that key, that means that letter had the same count in both. And if every single one of them is true, then we know that these two things are loose equal. Okay, let's try it out. We did it. All right. Yeah, and Amal is mentioning im log m becomes just im now. So before, our sort word function was like im log m, but now this is a single iteration of the word to create the counts. So that's in, or we'll say im because every word has a different number of characters in it. And then loose equal is, well, object.keys is going to be one iteration because we have to iterate over it to get out the keys. And then every is up to, like in the worst case, im iterations. So this would be, and really this is another letter, H-I-J-K-L-M-M-K, let's call it K. So this is 2K, or just simplifies to K. And then this, I don't know if I want to do, so this is going to be im. Let's call this in. And count letters is going to be im, and then loose equal is going to be K. So now, yeah, I think now instead of in times im log m, it's just in times im. But I think that's actually worse than im log m. Maybe I'm not calculating that correctly. Either way, this is ultimately less iteration than the other solution. Okay, last thing is we'll convert this this into a map, well, sorry, into a filter rather than doing the for loop thing. So ultimately, anagrams is going to be words dot filter. It's going to give us the word. And we want to return loose equal of the word of count letters of the current word. So count the letters of the current word in the given array, and then make sure that that is loose equal with the letter count of the input word. And then ultimately, we just want to return this thing. Okay, let's see what we got. And did I do something weird? I'm getting crazer in this array. Why am I getting crazier? We're still using these two functions we defined up here, which should still work. Oh, well, no. You know what it is? Our loose equal here, because we need the keys of the object that has. Here's what's happening. When we do a loose equal comparing like Crazer and I guess what was the input array? Racer. It's true because this has every character inside of here, but it also has a Z. So we need to do a couple of things. We need to first make sure that they have the same number of keys, and if they don't, we instantly know that they're not equal. So let's do this. So let's store object1 keys in a variable. And we'll store object2 keys in another variable. And if object1 keys dot length is not equal to object2 keys dot length, then return false, object2. Because we immediately know that they have a different number of keys. That does it. Okay, this might have increased. This increases the number of iteration because now we do have to find all the keys for the second object, but should be okay. All right, I'm going to submit this solution. There's that, and then I need my two little functions, loose equal and count letters. Okay, attempt. Test pass. I just thought of another thing though. Don't know like how efficient this is, but instead of doing all of this business here, we can actually stringify it, the objects, and then just make sure that the stringified version equals each one. If we do json.stringify object1 and make sure that that is equal to json.stringify object2, that should tell us that they're at least loose equal also. Oh, let's comment this one out. Whoa. What did I do? Never mind. Never mind. Something like that should work though. I don't know. Okay. Submit final. Drum roll, please. Cool. Yes, and so this person used the sort method that we did initially, and then just used a filter instead of a regular for loop. Cool. Sorting, filter, and sorting. Oh. Oh no. Oh. So this person is sorting the input word every single time inside of the filter. Every single time. You don't want to do this. It's much better to store it outside of the filter, so that way you only have to do that sorting once and then compare it inside of there. Same thing. Everybody goes the sorting route. This person's using Lodash. That's cool. I didn't know you had access to that inside of Code Wars. That's awesome. But they're doing basically we implemented functions that are inside of Lodash. So count by will create that object of counts, And then is equal does a loose equal comparison. So they're doing what we did, but they're using the built-in functions in Lodash to do that instead. Very cool. All right, moving on to RGB to hex conversion. Making decent time. I know this last one is going to take me a while, the one after this one, but let's keep on keeping on. All right. The RGB method is incomplete. Complete the method so that passing in RGB decimal values will result in a hexadecimal representation being returned. The valid decimal values for RGB are 0 to 255. Any RGB argument values that fall out of that range should be rounded to the closest valid value. The following are examples of expected output values. Cool. So in this case, 300 is over 255, so it gets rounded to 255. And again, they don't have any test cases for us, so we'll try it out, but then we will have to submit the solution to see if it works. Okay, this one is RGB to hex. Okay, so each one of these variables is going to be a number. First thing is we want to make sure that it's between 0 and 255. So let's write a function to do that, because then we can put each variable through that. So let's call this like normalize or within range. So this is going to take in a value, and we'll write it out with if statements first, but we can kind of do this as a ternary. So if the value is less than 0 and the value is greater than negative 255 divided by 0, meaning they're like, well, actually, no, if the value is less than 0, we just round up to 0. Cool. If value is less than 0, return 0. Else, if value is greater than 255, then return just 255. And else, else we just return the value. So basically, if they give us a negative number, we're going to give it 0. If they give us a number greater than 255, we're going to give 255. Otherwise, we're just going to give it the number itself. Cool. So that should take care of that. And then in JavaScript, there is a way to convert a number to a given base. Let's look it up on MDN. String prototype to string. No, number. Number. Yes. And actually, they show an example of it right here on MDN. So toString will take in the base that you're converting it to and just give you back that exact number. So for instance, if we take the number 255 and say toString 16, because hexadecimal is 16 different characters to represent each digit. So that, that will give us FF. Cool. So we want to do that with every value, and I guess also capitalize it. So let's say toHex is another function that will take in our value and then return value.toString 16 and to uppercase it because we want it to be in the hexadecimal format. Let's see what happens. So we're here going to return, let's do a template string. And we basically want to pass our number into both of these functions. So let's write another function that does that. So let's say convert. We'll take in a value. It will pass that value into within range. So we'll say within range value, and then it will pass this into 2 hex. Okay, so we want to convert R, G, and B. Okay, let's see what happens. Let's just try it out. Let's take a quick stretch. So if we say RGB of 255, 255, 255, we should get FFFFFF. 1, 2, 3, 4, 5, 6. Cool. And if we also do 0, 0, 0, we should get 0, 0, 0, 0. So 6 zeros. 1, 2, 3, 4, 5, 6. Two uppercase is not a function. Is it two uppercase? Yeah, you gotta capitalize the C. So when we did it with zeros, we only got back 3 zeros. So if we say 0.toString 16, we get back a single 0. So we actually want to pad this with a 0 in front of it if the value doesn't have, if the hex version only has one character in front of it, in it. Okay, so to hex, let's write another function. So we'll call this pad. So we'll take in a value. And if the value dot length is 1, then we want to return 0 plus the value. Otherwise, just return the value because the length should be 2. So our conversion function now wants to do all 3 things. So 2 hex within range. Actually, we could use pad within 2 hex because technically that's where we want to do that. There we go. All right, let's try it out. And actually, let's convert this to a ternary. So if value is less than 0, then return 0. Else, if value is greater than 255, then return then return 255. Else, return the value. All right, look at that. Nice little functions. Let's give it a try. Attempt. Test pass. Submit final. Drum roll, please. There we go. All right. Let's see what this person did. I guess that easy enough. So if the value is less than 0, just 0, 0. If it is greater than FF, so they're kind of like doing the conversion before passing it in. And then, oh, interesting. So they're always putting a 0 in front, but if there was 2 characters, slice will take off that 0 because they want it to only be length 2. Cool. And 2 uppercase the whole thing. This person is doing a map and then a join and then a two uppercase. Thanks, Rand. You can tell I'm getting tired at the end of the stream because I literally just coded it. I didn't explain it much before I did it. But all right. That was fun. On to the very last one of the night, which was suggested by James. James, I don't know if you're here, but this one is a doozy. It has an extremely long explanation too. Do I want to read this? I'll read the first paragraph, and then we'll look at the example to kind of talk about what it wants. All right, so this one is called Priori Incantatem. In the world of Harry Potter, Incantatem maybe? Incantatem. In the world of Harry Potter, each witch and wizard has a wand, and each wand is used to cast spells. Alaram opens locked doors. Expelliarmus disarms an opponent. And Avada Kedavra is the unforgivable killing curse. Oh, I shouldn't have said that. Well, this is real world we're living in right now, at least I think. But the futuristic VR company you work for has set the ultimate goal of creating a virtual world that models as close as possible the magic realm of Harry Potter, and you have been assigned the task of implementing the wand class. Cool. James is here. Awesome. Rand says he's fried. I'm kind of fried too. What platform are you coding on? So you might be talking about my editor. I am using VS Code. And I do have lots of different plugins installed. But the theme I'm using is Monokai Dart, SETI Monokai. Yes, and I just cursed you all with the unforgivable curse. Hopefully you forgive me. But this one is interesting because you can kind of do it like in a test-driven style. Can't seem to expand these columns, but basically, if you've ever done something test-driven, you're kind of testing things like as building blocks. So like, can you create an instance? Can you do this basic thing? Can you call this next function? So as we code this, we can try to solve like one test at a time. Like the first test, just make sure we can create an instance of a wand. And then the second one, make sure that when you pass something in, something happens. And then the next one tests a little bit more complexity and then calls other functions. So when we're solving this, we can just try to make each test pass one at a time. But the main thing is, let's see how this thing works. So you have this wand class, and you give it an object with the different spells that the wand can do. And the object has properties, which are the name of the spell, and the values are functions that just do the spell. It like logs something to the console or something like that. So after you create a wand with that object, that wand will then have those properties on it, and you can call them. And then there's also this Priori Incantatem spell that when you call it will return all of the previous spells that have been cast. So if you call each one of these one at a time, when you call Priori Incantatem, it's going to give you an array of the names of all the spells that were previously cast. Okay. And this returns that, but after you call Priori Incantatem, you actually do want to put that into the array. So the next time you call it, it gets put in there. And yeah, there's one more thing. Deletrius. If you ever call Deletrius, then that should clear out, or Deletrius. I'm probably pronouncing all of these things wrong. All the Harry Potter fans are going to hate me for this. But Deletrius will empty out that array and only have itself in there the next time you call Priori Incantatem. That's the main functionality. Let's get started. Okay, so first thing, let's make this first test pass. Expect new wand to be an instance of a wand. So for that, I'm just going to use the... I really wish I could expand and collapse these columns. I guess I can't. For that, I'm just going to create a class wand. Easy as that. So this will result in a new wand being an instance of a wand. So run your sample tests. First test passing should result in an instance of a wand class. All right. The next one is should correctly add spells to a wand. So this is giving us an object. So we need a constructor with the spells. And we basically need to create properties on the instance that are functions of the spells that were passed in. So when you pass this into the wand, afterwards you need to be able to say w dot one of those functions, and it should actually exist. So there are lots of different ways to do this. I guess one way I'll do it is just to iterate over the keys of spells and then add it as a property on this, because this is the instance. So let's do object.keys of the spells. And for each one, we're going to get the spell. And we want to say this, which is the instance of the class, at that spell is equal to spells at that spell. So this will create a property on the instance of wand that has the name of that given spell, and its value is going to be the function that was inside of that object. So we're essentially taking this object and putting all of those functions onto the wand itself. So let's run the sample tests. Cannot convert undefined or null to an object. I think we need to make sure that spells actually has some things inside of it. I think they're testing it with an empty object. So let's say spell names is object.keys. Let's check this real quick. If you do object.keys of an empty object, what do you get back? An empty array? You do get back an empty array. So maybe they're passing in something weird. Let's try this. Let's do spells or empty object. Oh, that's why. Because in the very first test, they don't pass anything in. So if spells is nothing, we'll just give it an empty object so it won't do anything. Let's try that. Okay, cool. So first passing test, we get an instance of a wand. Second passing test should correctly add the spells to the wand. And James caught it. So spells is an optional argument, so we need to account for that. And actually, we could use the ES 2015 default syntax. So what this does is if they don't pass in spells, then it gives it the value of an object. So that works. Cool. So now we need Priori Incantatem, which returns a log of all the casted spells. So notice what's happening. We create the wand with those spells. We then invoke each one of those spells. And when we call Priori Incantatem, we need an array of all the previously cast spells. So one thing we're going to need, we'll say this.casted. We need an array to store when each of those functions was called. And then we need our Priori Incantatem, which will just return this.casted. So it should return that array of casted spells. Cool. But one thing is, we need to know when they invoked the functions. So one way we can do that is when we're adding all the properties here, we could like wrap the function. So instead of just setting it as this function itself, let's do this. We're going to set that equal to a function that, so that invokes that function, but before it calls that function, it will push that function name into the array. So this .casted .push spell. So when we're putting the function on the instance itself, instead of just directly putting the function, we're putting our own wrapper function that when it's called, pushes the spell into the array and then calls the function that they gave us to begin with. We don't want to push. So we actually want the most recently called, most recently called to be at the front of the array. So instead of pushing, we can do an unshift. Sample tests. Rand, cheers. I'll see you later. Thanks for watching. Thanks for tuning in. Okay, we have the basic test passing. James is saying, can you put it in constructor argument as if it were required? I think this may be what you were talking about right here. Basically, this says you can't make it required because a JavaScript function can be called with no arguments or many arguments. Like, you can do whatever you want. But what this does is says, if they call it without that argument, make it an object instead. Okay, we have the basic test passing. One last thing, I guess, though, is there is that deleterious function. Let's take a quick stretch. Okay. The where is it? Deleterious. Deleterious should clear out the array. Deleterious? I don't know. I'm saying these things wrong. Deleterious should clear out the array and only have its own name inside of it. So this dot casted is just that. Cool. It looks like they weren't testing for that in the sample test, though. All right, let's do the full attempt. 62 failing tests. Okay. The first one that fails is should include calls to itself in the returned array. So expected priori incantatem instead got just a. So one thing we're not doing is when you call priori incantatem, you want to return the array without it in it, but you also want to put it in there so the next time it actually has it. So let's say we need casted will be an array with this, the current value of this dot casted, and we'll say casted dot unshift. Actually, we want a copy of that array because we're going to modify this dot casted. So we'll create a copy of the casted array and set that to casted. Ultimately, we're just going to return casted because that will return the array without priori incantatem inside of it. And then we're going to then unshift priori incantatem on this dot casted. Okay, here's where it gets tricky. Should work when methods are assigned post-construction. So you create a wand, then after creating the wand, you say wand.newSpell equals a function. And then when you invoke that function, it should still get pushed into the array. So here is where we need to actually do the tricky part, and what makes this thing so hard is we need to watch the instance of the wand for property addition, or like when a specific property is getting called on it or retrieved, so that later on, if they add new spells that weren't included in the constructor, we can still keep track of those. Is it ES 2015? But there's a thing called a proxy. And the proxy object allows you to tap into, sorry. This allows you to tap into if someone is retrieving a property from an object or setting a property on an object. So you can create a proxy that you can essentially keep track of when things are happening to your object. I have a video on one of my playlists where I actually use a proxy. So you can think like in a front-end framework that's watching for changes on something, they might be using something like a proxy, right? Because, like, for example, Vue.js is not using a proxy, but in a more recent version of Vue.js, they're going to start using proxies. But the idea is when you change a property on data, using a proxy, they can now know that something changed and then update your view. But I did a talk a while back. It's on the JavaScript playlist called the Front-End Face-Off, where in a little under 30 minutes, I made like a toy MVC framework from scratch, and I used a proxy inside of there because basically I wanted to know when a property on data changes, automatically update the view. So if you check out this video, you can see how I used it there. But that is what we're going to use here. Okay, so here's what we got to do. So let's keep track of when a function is retrieved. Because the moment a function is retrieved, we know that they're about to invoke it. Meaning, like when you see code like this, w.newSpell, before you invoke that, you have to retrieve it from the object itself. So we're going to create a proxy that listens for when something is retrieved. If the thing that was retrieved is a function, push its name into the casted array. And then just return that value. So we'll do that here. And the interesting thing about classes in JavaScript is if your constructor function returns something, then that will be your instance. So we are going to return a new proxy here. And a proxy accepts the target. So what is the thing we are watching for property retrieval? And that is this. So we want to know when someone retrieves the property from this, let us know. So we'll do this. And then you give it an object of options. And the one that we care about is get. So when you retrieve a property, if it's a function, put its name in the casted array. So inside of that object, we'll do a get. It has the target, which is the instance itself, the property that you're retrieving, which would be like the name of the function, and then receiver, which we shouldn't need. So here. So we're going to say get is a function that takes in the target and the property. And what do we want to do? We want to say, if you are retrieving a property that is a function, put its name in the casted array. Jiraj is saying, why am I doing exclamation mark before MDN proxy? So I use DuckDuckGo as my search engine, and DuckDuckGo has a lot of different bang shortcuts. So you can just search DuckDuckGo directly, but if you do bang G, it'll search Google, bang W will search Wikipedia, bang GH will search GitHub, but bang MDN will search the Mozilla Developer Network. So I'm basically just doing a direct search to MDN for the word proxy. That was when I did that. Because you'll see it goes to DuckDuckGo and then it redirects. Cool. Okay, so here's what we'll say. We'll say if, and let's just, let's store this in a value, because target is going to be the instance. So that's like an object. And then property is the thing that we're retrieving. So we'll say value will be target at that property. And we'll say if the type of value is equal to function, then we want to push the property name into the casted array. So we'll say, should be able to say target dot casted dot push or unshift the property. And just to make sure that that works, like if you say type of some function like that is the word function, cool. So if they are retrieving a function from this instance, put its name into the casted array, and then get needs to return like whatever value that they were requesting to begin with. So we're actually just going to give back that function. But now that we're doing this, we actually don't have to do this anymore. So now this will work for anything So we shouldn't have to unshift it there. We should be able to just say, when you pass in the spells, just put it on the instance. And then later on, if one of those spells is retrieved, then put its name into the casted array. And we no longer want to unshift. We no longer want to, we no longer want to do that inside of there. We really just want to return this without the first value inside of it. Because when they called Priori Incantatem, it would have unshifted inside of there. And Priori Incantatem should not have itself inside of there. So we can do this.casted.slice 1 and does slice modify or return a new array. Returns a shallow copy of a portion of an array into a new array object. Yeah. So if I say slice of 1, then it will not include it will not include Priori Incantatem, which just got called. Okay, let's give this a try. All right. Okay, one thing we're not taking into account is max prior spells. So if we look at the instructions, this casted array should only include up to a maximum number, and right now we're unshifting every single function name. So we only want up to max prior spells. So we should be able to slice this array with max prior spells, because that will, or we might, let's see how slice works. End is not included, so we do want to do +1. So this will give us an array without Priori Incantatem up to the maximum number of spells that they specified. Go! We did it. Okay, I'm going to pull this down. We'll kind of examine what's happening here. What is this called? Yeah, Priori Incantatem. Incantatem. And we need to say like max prior spells equals some number. Okay. One thing we can also do though is because we're just setting the value on the instance here, we can actually use object assign. So we can say object.assign. We want to assign this with the values that are in spells. And that basically does the same thing as keys and then for each, because it takes every property on that object and just puts it on the instance. So that should do the same thing. And just to see this happening, let's run one of their test cases locally, so we can kind of break down what's happening there. Okay, and here's what we'll do. Inside of this proxy, let's just create a log. We'll say getting property, and then we'll also say adding spell, because it is a function, property name. So if we run this locally, you'll notice that every single time we invoke a function, it's actually getting the function. So like in this line of code right here, because we are invoking it, our proxy is kicking in and saying, hey, you're grabbing the Alarama property. So that's running. And then we add the spell because we know that we're grabbing it. Same thing for all these other function calls. And you'll also notice when we called Priori Incantatem, because inside of that function, we're accessing this.casted, our proxy kicked in also and says, hey, you're grabbing the property casted. So the proxy is keeping track of everything that is being retrieved from this instance, whether it's a function or an object or anything else like that. Okay, this has probably been one of my longest Code Wars, Code Kata streams. So let's submit our final solution and see what happens. Okay. Drum roll, please. It worked. Awesome. Okay. Let's see how they solved it, and then I'll end the stream. This has been a long one. It was fun. We did a lot, but yeah, it's been a long one. Okay. So yeah, they did the object assign thing. So basically that takes the object of spells and puts it on the instance. They are defining properties. Interesting. So they're saying cast is an object that is not writable, meaning you can't overwrite it, but you can still push into it. Priori Incantatem is a function that does what we did. So it slices off the first one and returns max prior spells. And then Deletritus uses reflect. So reflect is another thing that kind of goes hand in hand with a proxy. Let's look at proxy. Reflect is a built-in object that provides methods for interceptable JavaScript operations. The methods are the same as those of proxy handlers. Reflect is not a function object, so it's not constructible. Interesting. So it's basically, it has like static methods that do what handlers in a proxy would do. So this is setting the value on this.cast, which was set there, to be a length, to have a length of 1. Yeah, so it's just resetting it to only one length of 1. And then their constructor function is returning a proxy. And they are making sure it's a function. Then they're using reflect.get. I believe I was just using target.casted because in your handler, target is the thing that's being proxied. So target is actually equal to the instance of this, so it should have the casted array. So it might be better practice to use reflect.get instead. Don't know. But then they unshift it and wait, what? This is really interesting syntax. What I did was just store the value, unshift it, and then return the value. They're returning an and. I would think that would return a Boolean instead of the actual property. Weird. Okay, this person's very similar solution as to what we did. So they have their history or like casted array. They do object assign. They unshift it and return it. Main difference is we're storing the value and then just always returning that afterwards. Lots of interesting solutions. All right. I think that's it. Thanks everyone for tuning in. Thanks for participating in the chat. Thanks for watching. If you're new to Coding Garden with CJ, I do have some upcoming streams. So tomorrow morning, I'm going to do a morning tea stream at 10:30 a.m. Mountain Time. And tomorrow evening, I'm going to be building a full stack Reddit clone. So we'll have login, we'll have creating subreddits, submitting links to subreddits, upvoting, commenting, the whole thing from scratch tomorrow. And I'm going to be using Vue.js and Firebase Firestore. I will be posting my streams for next week as well, so look out for those. And look out for an announcement. Special incoming stream on Saturday. I will most likely announce that tomorrow. All of the code I will push up to GitHub. The link is in the description, but I'm going to push it up to this repo so you can take a look at it. And that's it. Thanks for tuning in. Thanks for everyone for participating in the chat, and I will see you next time. Wait, before I go, we have not done the fish cam tonight. I think he's sleeping in his home. His tail is sticking out, but he's asleep. We'll leave him alone. All right. Have a good morning, afternoon, night, wherever you are in the world. I'll see ya.